um, videos about length of curves. Okay, so consider any curve, right? Right, which is given by a parameter, right? So we start at A, we end at B, and so at each point t, right, we're given, r of t is a function that gives us a point. So between, this is a function between this interval a b and then a point. It could be in Rn, any dimension, right? And we're going to go for points in the plane, for instance, right? Because this is what we know how we have been working with, but we generalize this for any curve, right? So one way to think about the length of a curve like this, let me maybe simplify this, something like this. Okay, you can think of any kind of curve which you parameterize with a function r, right? We can think of, how to integrate the length. Is you can approximate the length of this curve by doing a partition of this interval between a and b, right? As usual. And from each partition in this interval, you have a segment that joins these points. Well, this is t0, t1, t2, t3, right? So you substitute your curve by a polygonal approximation, right? These things are segments, right? And we know how to compute the segment of this, because that's just the norm of this the point. This is r at ti, and this is r at ti minus 1, right? Well, the length of the segment is just the distance between these two vectors, right? Right, that's the norm. So we can just sum this between I1 and n, and we get an approximation of this length, right? Now when we refine the partition using our regular scheme, we get to a very better and better approximation until in the limit we get to the actual length of the original curve, right? Now how do we get a formula out of this instead of just writing this approximation? Well, we want to get, again, something that has ti minus 1, so that we can integrate as in this function t from a to b, right? In order to have this, well, the easiest way is to just multiply it and divide it, right? But then we have this thing here, which is the norm. This is numbers, so we can divide a norm by a number, and this is the same as the norm of this vector. Right? Now what is this? If we take the limit when ti and ti minus 1 are very close together, this is just the derivative of the limit when ti goes to ti minus 1, or the other way around is, or let's say ti minus 1. Well, yeah, don't worry about too much about that. The limit of this thing is the derivative, the norm of the derivative of r at ti, right? That's what this is going to happen. So what we are integrating over, right, between when we get the length of a curve, right, is the integral between a and b of this norm, the norm of the derivative of r at that point t between a and b, right? So that's going to work whenever we can write our curve as in terms of parameterization of t. So let's see how we can work this out. In some cases you're going to have to think about the parameterization, but in some cases it's given like that. So for instance, you have a circumference of radius a, okay, in any this is the curve c, right? This doesn't matter the origin. So we can parameterize it like this, rt, and this is, you can see this is a sequence of points in R2 in the plane. So the parameterization is a vector of two components. The first one is a cosine of t a sine of t, right? So if you are in the origin, you start at 0, the cosine of t is 1, right? So the times a, so this is a, and a times of 0 is 0, so the first point is a 0, right? And then you start increasing, you get to pi halves, then the cosine is 0, and then this is 1, and so you keep going like this, right? This is what it's parameterization of this curve, right? Now, what's the length of the area? It's obviously, the length of r is obviously a, right? You can see all the times a squared times the cosine squared plus a squared times the sine squared is equal to a squared, and the square root of that is a. But the derivative of that, we haven't seen so far functions with two components, but the derivative of that function is the derivative of the components. So this is minus a sine of t, a cosine of t, right? But this is again, the norm of this is the square root of a squared sine squared of t plus, and then a squared cosine squared of t. So sine squared plus cosine squared is 1. You get common factor a squared, so this is just a, right? So the length of this curve is the integral between 0 and 2 pi of a dt. But now this is a constant function between 0 and 2 pi, you have 2 pi a, which is the length of a circle of radius a, as we all know. Okay, but this can get very interesting and many interesting applications that we will see in the exercises.